In this recording, we're going to continue our study of the locus definition of a parabola using the focus and directrix. And here we're going to get into some algebra where we need to actually find the equation of a parabola that has particular focus, in this case 0, 7, and directrix, y equals 3. So the first task, it says, is you're going to sketch a diagram of this and identify its turning point. I'd like you to use this grid to sketch the line y equals 3, the point, the focus, 0, 7, and then try to make a parabola that has all points equidistant from those two features. And play the recording when you're ready. All right, so I'm just going to sketch this out, and you'll get to see it sort of in rapid speed. So therefore we know the vertex must be in the middle, right? There's our focus. Here's our directrix. So our vertex must be the point 0, 5. And then you can just sketch out your parabola the best you can. And now we're ready to work on part B, which is to determine the equation of the parabola using the locus definition. And basically we're going to do the same thing every time. We're going to find the distance from any point to the directrix, that line there, and then from any point to the focus, that point. So if I were to take an arbitrary point, call it xy, its distance to the line y equals 3 is whatever the y value is. So let's say the y value is 10, the distance would be 7, right? So I just take the y value minus 3. So this distance is y minus 3. Whereas this distance, you can see I didn't sketch perfectly, fine. Those distances should be equal, use your imagination. This distance, we'll call this d1, and this is d2. I need to find out what this distance is, set them both equal, and solve for y. All right, so I'll kind of do that workout here. First, the distance from the point xy to the focus would be d equals, and I'm using my distance formula, so it's x minus 0 squared plus y minus 7 squared. All right, and I'm going to set that equal to my d1 here. So we're going to do y minus 3 is equal to that expression above. Now we just have to do the math here. So I'd like you to square both sides. Squaring the left side's easy because the square and the square root are inverses, so you just get what's underneath, the radicand. Squaring the left sides, you gotta work it out. So you might want to come over in this space and work it out. And when I square, we just get x squared plus, when you work all this out, at this point, we can say add to 0. Let's get all the y's on one side. So I'm going to add 14y. So we've got 8y. Let's subtract. So I've got 8y equals, those add to 0, those add to 0, x squared plus 40. Now I just need to divide. And there's our equation. So now at the bottom it says, hey, this is tough. The hardest thing that we're going to tackle in this course would be a parabola whose focus is not on either axis. But we will have horizontal lines as our directrices. All right. So I'd like you to get as far as you can with this final example. I'd like you to do just what we did before. Make your sketch. I would like you to identify the distance between the focus and the point xy and the directrix and the point xy. Set those two distances equal and solve for y to get your equation. Play the recording when you need a hint or you want to check your answer. So now we know the point 4, -1 is your vertex, because it's exactly 2 units from the focus and exactly 2 units from the directrix. So we know it's got to kind of curve like this up, so it curves around your focus. Just kind of do your best to make a curve, just so we get a sense of it. This is just a sketch, so that's our function. And then let's label any point on there, call it xy. All right, now let's proceed to find those two distances. So that's going to be d equals, well, whatever this y value is, you're going to add on 3, because there's another 3 past the x-axis. So it's going to be y plus 3. Call that d1. And there's d2. The point xy to the focus is going to be your distance formula. All right, at this point, we're going to set both of those distances equal, because that's just the definition of the parabola, locus definition. Square both sides, work this out. So I'm taking a shortcut here with the squaring of the binomial, but you should write it out twice. Make sure you're getting that right. Okay, again, if you're not seeing where I'm getting this, write it out. X minus 4, expand it all out. These, but you're going to have to write them out. All right. At this point, we have to clean up all the algebra. So I see a y squared adds to 0 on both sides. I can subtract it, y squared on both sides. I see a 2y that I want to add to the left side. That gives me 8y. Okay, so that's out of there. I see a 9 I want to subtract from both sides, so I'll just subtract that here and here. Okay, so it's going to give me on the, it adds to 0. So on the left side I've got 8y, on the right side I've got an x squared. I have a negative 8x. And I have, well, 16 plus 1 is 17, minus 9 is 8. Okay, so it's going to work out nicely. Dividing through by 8. And that's our equation. Thanks for watching.